Lesson 88 is on solving quadratic equations. Now, before we talk about what a quadratic equation is, let's just review some polynomials that we know about. The standard form for a polynomial in 1 degree, like an equation of a line, that's y equals mx plus b. Now, a quadratic equation, that also has a standard form as well for it. And this is what it is: ax squared plus bx plus c equals 0. So that's the standard form for a quadratic equation. It's a second degree polynomial. We have these standard forms for equations like these because they are used a lot by a lot of people all around the world, and so we want to have a standard way of writing them so that everybody kind of is on the same track. So two equations that you need to remember what their standard forms are a line, y equals mx plus b, where m is the slope of the line, b is the y-intercept, and then a quadratic equation, ax squared plus bx plus c equals 0. Now, the equations of a line, we've been graphing those lines on an xy axis. We won't be doing any graphing with the quadratic equations. What we'll be doing with those is just finding solutions to them, where a is a certain constant, b is another constant, and c has a certain numerical value to it as well. Let's just learn about solving quadratic equations by doing some practice problems. Look at practice problem A. X squared plus 4x plus 3 equals 0. Now that's a quadratic equation. A is 1, B is 4, and C is equal to 3. Hopefully that looks familiar to you. Up to now we've been calling the terms on the left of the equal sign, we've been calling that a trinomial, and you've been factoring those into two binomials. And that's what you do as a first step to solving a quadratic equation. So go ahead and factor that into two binomials. Put your parentheses down. And so you think of two factors of 3 that if you added them together would equal the 4, and that would be a 3 and a 1. So you just say x plus 3 and x plus 1 equals 0. Now, we're trying to find the solutions or roots to this equation. And what we want to do is make the left side equal to 0. So what you have to think about is everything inside the parentheses is a factor. So if we make one of those quantities inside the parentheses equal to 0, then it'll be a factor of 0 and the whole side will equal 0. So if we use negative 3, that would work, right? Because we'd have a negative 3 plus 3, and then negative 3 plus 1. This would become 0, and it would make everything equal to 0. So that's a root of this, or solution to that equation, is x equals negative 3. And then the other one would be a negative 1, because if we had negative 1 plus 3, and then negative 1 plus 1, this would equal 0, and we'd have 0 times a 2, which equals 0. So x equals negative 3 and negative 1. Those are the roots, or sometimes they're also called zeros. They're the values that make that equation equal to 0. It's really, really simple to figure out what your zeros are of these quadratic equations after you factor them into two binomials. Hopefully you notice that they're just the opposites of the numbers inside the binomial. So plus 3, you make it a minus 3. That would be a 0. Plus 1, you make it a minus 1. That's another 0. As long as one of the two factors is equal to 0, then the whole thing equals 0, right? A way to describe that is something called the zero factor theorem. And if you had two numbers, p times q equaled 0, one of those numbers has to equal 0 in order for p times q to equal 0. Either p is 0, q is 0, or both of them equal 0. That's called the zero factor theorem. That's just a truth about that property. And so we apply that to solving quadratic equations. If one of those two factors is a 0, or equal to 0, if we substitute a number in for x to make one of those two factors equal to 0, then that number we substituted in is a root or 0 or solution, all those things mean the same thing, for that quadratic equation. Let's do another one. 5x minus 14 equals negative x squared. Now what you want to do to solve that quadratic equation, you can see it has an x squared in it and x in a constant. You need to get it in standard form. Just like when we're trying to work with an equation of a line, we always want it in standard form first before we try to graph it and figure out what's actually going on with that equation. So get this in standard form. That means a 0 on the right side, so we would add an x squared, a positive x squared, to both sides. And we'd have x squared plus 5x minus 14 is equal to 0. Okay, now we can factor that into two binomials. Have x here and x here, and we need two factors of 14 that would add up to a positive 5. And so that would be a plus 7 and a negative 2. Okay, so our zeros for this equation, to solve this equation, x would have to be the opposite of 7, so that's a negative 7, and the opposite of negative 2, that's a positive 2. Those two values would make the left side equal to 0. Let's do one more. Look at practice problem C. X squared equals 9. Now that might kind of confuse you at first. There's no x term in there, but that means that b must be 0 in the standard form of a quadratic equation. So you just have an x squared and a constant. So try to get it in the standard form, and so you'd subtract both sides by 9, and you'd have x squared minus 9 equals 0. Now, hopefully you recognize that you have a difference of two squares, and that's always what you have to do on those problems where you have a squared term and then a constant, is if you recognize a difference of two squares, then you can factor that into two binomials, x plus 3 times x minus 3 equals 0. And so your roots, therefore, are going to be a positive 3 and a negative 3. And you could just write that plus or minus 3. You could make that the solution, plus or minus 3. That's another way to write it. So be careful when you see a problem like that. You can still get it in standard form. You just have to recognize that you are working with a difference of two squares. Let's look at one more quadratic problem to solve. And we have 4x squared minus 9 equals 0. So it doesn't look like the standard form because there's no x term, but that just means that b is 0. So we need to recognize there, do we have a difference of two squares? Well, yes, we do. And so let's factor that into two binomials. The first one we can say is 2x minus 3, and the second one, 2x plus 3 equals 0. Okay, so now what we're trying to do is make one of those two binomials equal to 0. What value of x could we put in there that would make that equal to 0? So a problem like this, it's a little more confusing because we have a coefficient in front of x. We can't just take the opposite of the constant term there, because if we just said, like in the first binomial, oh, well, positive 3 would work, no, it wouldn't, because that would give us 6 minus 3 instead of a 0. So what we need to do, and this might be a little confusing, but just think about it. That on the inside has to equal 0. 2x minus 3 has to equal 0. And then we also need to say 2x plus 3 is equal to 0. So what we can do now is just do some algebraic addition, use our additive property, use our multiplicative property, solve for x in both of these equations that we have just made. We know that that quantity, 2x minus 3, has to equal 0. And so to figure out what would make it equal to 0, we just set it equal to 0. And so take 2x minus 3, and over to the right here, we would end up with 2x equals 3 because we could add a positive 3 to both sides. X equals a positive 2/3. And then likewise, you could see that x equals a negative 2/3 in that bottom equation. So x has to be plus or minus 2/3. Those are the two values for x that would make that left side equal to 0. So those are the roots or zeros for that quadratic equation. So we had to think a little bit more on that one. We just had to set what was inside the binomial equal to 0 and solve for x that way. That's what you'll have to do when you have a coefficient other than 1 for the x term. Okay, well that's all for lesson 88.